Welcome to Theory Inquisitive Kids. In this video, we're going to be learning about how to solve irrational inequalities. Let's get started. Here's our first example. We're going to try to find the solution set of x given this inequality. Our first step when approaching these type of problems is to always state the restrictions on the domain. We see a radical here, and we know that anything that's underneath a radical must be non-negative. It cannot be a negative number. So we can set x plus 6 to be greater or equal to 0. And we also know that a radical can output only a 0 or a negative number, which means x minus 6, the output of this radical, must be greater or equal to 0 as well. So let's solve for x. This tells us that x must be greater or equal to negative 6, and x must be greater or equal to 6. Well, we can just combine these two to say x is greater or equal to 6. Now we can actually go ahead and solve for the solution set of x. We're going to square both sides. On the right-hand side, we do a perfect square. It would expand out to become x squared minus 12x plus 36. Then we could go and move all of our terms to the right-hand side of the equation. Now we can factor our quadratic. This quadratic factors out to become x minus 3 times x minus 10. Now, how can we move on from here? Well, let's think about it. Imagine we had a parabola, which we do actually have right now. This parabola is defined by x squared minus 13x plus 30. And we know this parabola is opening upwards because the coefficient of the x squared term is positive. This line is when y equals 0. And now we're trying to find that beyond which x values, which is here and here, does the graph stay positive. It goes above the y equals 0 line. Well, we know that one of the roots is here, x equals 3, and the other root is here, x equals 10, which means that when x is less than 3 and when x is greater than 10, do we have the expression being greater than 0. So now, if we want to draw another diagram to make this more clear, we can plot out our important numbers, 3 and 10. And we know that we want x to be beyond these two boundaries. But remember, we still said that x must be greater or equal to 6. Now let me use a different color to represent this. Our original domain restriction was that x must be greater or equal to 6. So it would look something like this. Now, where does the red section and the blue section overlap? Clearly, we see it's over here. This is where we meet the requirements of the red as well as the blue. So our answer would be x can go from 10 to positive infinity. This is our answer.